Well, hello. We are going to be going over our Algebra 2 semester exam review. So I've picked a few problems for us to go over. Starting with number 1, we're solving and we have a radical equation. So we need to get the x by itself, which means first we need to get the radical by itself. So we're going to divide both sides by 2. When we divide both sides by 2, these cancel, leaving us with the square root of x plus 1 equals 7. Now to get rid of our square root, we're going to square both sides. And when we say both sides, we mean everything. So if you had a binomial on the right side, you would make sure that when you square it, that you do FOIL. On the left, our square root and our square sort of cancel each other out, and we're left with an x plus 1. And 7 squared gives us 49. Now to continue to solve, we would move our 1 over by subtracting 1 to both sides and get x is equal to 49. Okay, I also picked number 4 to work as well. And on number 4, you have exponentials. And notice our bases are different, an 8 and a 2. But I can make them the same base by turning my 8 into a 2 to the third power, because 2 times 2 times 2 gives me 8. And when I do that, 2 to the third, we know when we raise a power to a power, we can simply multiply those. So I really have 2 to the 3x, which is equal to 2 to the x plus 6. Once our bases are the same, then our exponents are equal to each other. So we know that 3x would be equal to x plus 6. Continue to solve, move your x over. When I move x over, I get 2x is equal to 6. When I divide by my 2, x is equal to 3. All right. The next one I picked was number 5, because if you notice on number 5, they have different bases, but there's no way I can turn a 200 and a 5 into the same base just with different exponents. So what we need to do on number 5 is we learn how to log both sides, because we know if we do anything to an equation, as long as you do it to both sides, then it's legal and it's fair to do. So on the left, if I log the left side, I'm going to have log, and I can choose whatever base I want. I'm going to choose base 5 because the base with my exponent is a 5. So that will be 5 to the x minus 2 equals log base 5. Have to keep the same base. Whatever log you add on the left side, you have to do the same one on the right. So that will be log base 5 of 200. We learned from our properties that if we have an exponent on a log, we can pull that log up to the front and make it multiplication. So this would become, in parentheses, x minus 2, which was my whole exponent that I've moved up, times my log base 5 of 5 equals log base 5 of 200. Now remember, we also learned a property as well that told us if we have a log to any base and the same number, that anytime these two numbers are the same, that's equal to 1. So in my equation, log base 5 of 5, this becomes a 1. When that happens, I just have x minus 2 equals log base 5 of 200. To solve for x, I could add 2 to both sides. Now, when I add 2 to both sides, you want to be careful, because on the right-hand side, this 200 is attached to the log. It's not a regular 200. So that is simply going to be log base 5 of 200 plus 2. Now, we could plug that into our calculator to see what that actual value would be. And remember, your log key is right above the x to the 10 key. So I'm going to do Control X to the 10, and notice it pops up with a log. I'm going to put my base, which is 5. Arrow out of the base, notice it puts you into the parentheses. That's my 200. Make sure you arrow out of the parentheses to put your 2, because that 2 doesn't have anything to do with the log. And so when I enter, I get 5.292. So x is approximately 5.292. Okay, now the difference in this equation and this equation when I have a log is, notice there's only one log. I don't have a log on both sides. I don't have an exponent that I'm trying to get rid of. So I can do our conversion and convert it to an exponential equation, which, remember, with our conversion we start with our base of 3. We're going to raise it to this power, and it will be equal to this number, which means I'm going to take my base of 3, raise it to the 2, and that should be equal to x minus 5. And if you notice, I know that 3 squared is 9, and then I have a very simple equation to solve. Just move my 5 over, and when I move 5 over, I get 14 is equal to x. And we're good to go. Okay, the next one I've picked to show you is another solving equation, but this one's a little bit different because notice it's a binomial. So I picked number 10, and number 10 has not a binomial, polynomial. We've got 4 terms in our polynomial, which means we can't just factor it using trinomial or FOIL, undoing FOIL. So what we're going to do is what we call factor by grouping. And factor by grouping means we're going to group together some things that we know will factor. For instance, I'm going to take the first 2 terms and group them together, and I'm going to take the back 2 terms and group them together. When I factor the first 2, notice the common factor between x to the third and x squared is x squared, and I'm left with an x and a plus 1. On the second one, when I factor that, the common factor between negative x, you can think of that as negative 1x minus 1, would be a negative 1, which would leave me with an x and a plus 1. So notice that gives me now 2 terms. Terms are things that are added or subtracted together. There's my 2 terms. Within those 2 terms, notice I have a common factor of x plus 1 in both of them. So I can factor out that x plus 1, and I will be left with, from this term, with an x squared, and from this term with a minus 1. I continue to factor because this is a perfect square binomial, difference of 2 squares. So when I factor, I still have my x plus 1. When I factor this second one, that gives me x plus 1 and x minus 1. And then we'll set each one of these equal to 0. So when I take my x plus 1 and set it equal to 0, I get x is equal to negative 1. If I did x plus 1 again, notice I'm just going to get the same number, and I don't have to write it twice. Once is enough. And then when I take x minus 1, set it equal to 0, I'm going to get x is equal to positive 1. So both of those answers are good answers for my x to the third plus x squared minus x minus 1. Okay. Now for some division. I picked 2 different kinds of division problems to work with you because the way they look. Notice the first one, we have a plain binomial, and our binomial has a leading coefficient of 1. Those were the really easy ones that we learned how to do synthetic division. Remember, synthetic division is sort of fake division. So that's where we had our little box, and we took our root, which we took this factor, and set it equal to 0. And when we solve it, when I subtract my 5 over, I get negative 5, and that's the number that I'm going to be dividing by. Then I'll take only the coefficients of my numbers. So I'm going to have an x, a 3, and a negative 10x. Sorry, a 1, a 3, and a negative 10. So I'm going to have a 1. I'm going to leave some space when I put my 3 so that this doesn't look like a 13. And then I'm going to have my negative 10. I'm going to leave myself some space so that I can do some work, and I'm going to draw a line. Now when we work these, remember we take the first number and we bring it straight down. When I bring it straight down, I have a 1, and then it's just going to make a circle. 1 times negative 5 gives me negative 5. I add down my columns. 3 plus negative 5 gives me negative 2. That's one cycle. Now I do it again. Negative 2 times negative 5 gives me a positive 10. When I add down my column, negative 10 plus 10 gives me 0. The last number is always our remainder. And then we will sort of go up with our values to determine what our polynomial will be here. The first term now becomes my constant. The next term becomes my x to the 1 term, and it would go up x to the 2, x to the 3, and so forth. So this becomes x minus 2 is what I get when I divide x squared plus 3x minus 10 by x plus 5. Now on number 15, the difference is when what I'm dividing by has a leading coefficient. When that happens, we have to do our long division. I know, quit grumbling. It's long, but we can do it. We have 2x plus 5. We're going to continue with these numbers. We're not going to drop the variables like we did with synthetic. We're going to keep everything. Also making sure that we have nice, neat columns. Notice they're in order, x squared, x, and number. And when I divide, I'm only going to be looking at that first term. So 2x times what gives me 2x squared? Well, 2x times x. And notice I have a column for my x's, so I'm going to put my x right here. When I multiply, x times 2x gives me 2x squared. X times 5 gives me a positive 5x. We normally, with division at this point, subtract. We know when we're combining like terms with polynomials, we like to do a plus a negative, which is the same as subtracting. So we're going to do plus a negative or plus a negative. And we're changing those signs if you notice. These cancel. That was the whole goal, was to get that to cancel. Negative 3x plus a negative 5x gives me a negative 8x, and bring down my negative 20. We continue looking at our 2x again, times what gives me negative 8x, and that would be a negative 4. Negative 4 times 2 gives me a negative 8x. Negative 4 times 5 gives me a negative 20. Again, we're wanting to change our signs so that when we add, it's like subtracting. We're adding a negative, so we're changing that sign. These cancel, and these cancel, leaving us with the remainder of 0. And so 2x squared minus 3x minus 20 divided by 2x plus 5 gives you x minus 4. So if you'd like to see some more, check out the next video. I will continue with the review, picking a few problems and working those with you to help you to see what you need to do. Thanks for joining us.